graphically do not match. So that's the leading theory that's been proposed, and the numbers don't work whatsoever. And I don't know. I don't know where the community goes from there.
Isn't the vacuum energy supposed to be particles popping in and out of existence?
That
The
is sometimes how
fraction of
it's
a
talked
millionth
about.
of a
Yeah.
second.
Um, that is one of the visualizations for it. Yes.
And how
And the
how do
idea
they
the
figure
idea that
that
it creates a
causes
certain
expansion?
pressure. The idea is it creates a certain type of basically pressure within space that does push on everything else.
That doesn't sound right. And the other thing you said before about the conservation of momentum,
Yeah.
uh, funny, I saw this video just the other day, and he rolled. I was trying to find the video while you were talking. Of course, I couldn't find it, but he shows an inclined plane, and he has a
Mhm.
car, and he times the amount. He has it from the sorry, from the top, and it rolls down, and he times it. Then he puts another car in between, and that car rolls down the same track, hits that car, transfers the energy, and it's exactly the same time.
Mhm.
So that shows that it transfers 100% of the energy from one car to the other. And of course, I can't
Um,
find the video.
I mean, was the other car free to move, or was it like
Well, of course,
parked in?
yeah, of
Okay.
course, it was free to move. It was in the path of the slope.
Yeah, no,
When he
I
put
mean, just have to look at it. I mean, one of the important things about the example I gave here is that the two objects are totally free to move, that there's nothing else that happens in the circumstance other than one singular collision, and that's it. So, I purposefully stripped away any other uh, thing, that could make the situation more complicated for it. So I need to look at you definitely can have situations in which there's 100% momentum transfer. You definitely can construct situations like that.
But it wasn't a difficult thing. It was like one cue ball hitting another cue ball, but in the form of a car.
Mm.
So he timed the car going down the slope without interference, and then he put another car in the path of it, and it was the same time, like he timed it, right? And it
What
reached
do
the
you
end
mean the same? What,
exactly the
what
same
was the same time?
as the car that wasn't hit.
So what was the same time?
Both, both the car that rolled down the slope free without hitting any obstacle, right? From one end of the
Yeah.
track to the other. Let's say it was 44.2 seconds. Then he put a second car in the path of that slope, right? So
Mhm.
one car rolled down the same exact track, hit that car, and the second car reached the end of the track at 4.2 seconds. So that would apply complete transfer of energy of momentum, would it not?
You're saying the time for one car to go down a track with nothing in the way compared to the time for one car to go partially down a track, smash into another car, and then have the other car continue down the track the rest of the way? Is that what the situation
Correct.
was?
Yes, correct.
Um,
So there was no
well,
loss of momentum at all. It was a
yeah,
complete
there shouldn't be loss of momentum. I mean, did the cars stick together?
no. One stopped, like when you hit a cue ball,
Yeah. Oh, yeah. Okay. Yeah,
first
of
cue ball
course.
stops and the second one rolls down.
Yeah, exactly. Yeah, that's a perfect situation in which you can see 100% transfer of momentum, where they don't stick together, where one of them hits the other, and the first thing comes to a complete stop, and the second thing keeps moving, exactly like the cue ball situation. Of course, totally. Um, yeah, that's a great example of 100% momentum transfer. I definitely did not say that momentum could never be 100% transferred. I just was saying it's conditional on how you set up the collision. I was specifically in the example I gave looking at examples where they stick together after the collision, not where they bounce off of each other.
Oh well, yeah, of course. If they stick together, obviously you're gonna have double the mass. And
Yeah.
maybe I misunderstood you. Maybe I misunderstood you because I thought you said there's no situation where.
Sorry, no. I meant in a collision where they stick together, or where there is some like even if they don't perfectly stick together, there's some release of energy, right? Like if one cue ball hits another cue ball, with like a nice just quick little click, and they're the same mass, and Yeah, that's a situation where you could get total momentum transfer. What you'll see though is that there's basically no energy released within the collision in a situation like that. Ideally, there wouldn't be. Like the ideal version of this is two elastic balls where there's a transfer of energy and momentum from one to the other. There's no impact crater. Right. So I was looking at, in my example, one that was meant to be more like a situation where you would see an impact crater where the two objects like crash into each other and merge and stick together.
Well, that's a whole different thing. Yeah, of course.
Yes, but I thought that that was probably more relevant to talking about a ball landing into the ground, which is why I was looking at that
Can
example.
you predict the object is going to either stick um or
What you mean just from looking at the speeds? No, no,
yeah, like
that's gonna
before an event?
no. I can't predict if they'll stick or bounce just from looking at the initial speeds. Not at all. That's going to depend on the so many things to do with the actual like materials that are in collision.
Like the density and the mass.
Uh, I don't know. I'd imagine it has to do a lot with how rigid the object is and how springy it is,
Mm.
whether it deforms or elastically bends, how shock waves transfer through the object, and just how sticky the surfaces are when they collide with each other. Like the example I gave was one that assumed that they stuck together, that we were dealing with materials that would stick together upon collision. If we're dealing with materials that are very bouncy, then we'd have to restart the whole analysis. We'd use the same basic equations of momentum and energy, but we'd have to go back to the beginning of the analysis and redo it because that would be a very different way for things to collide than for them to stick together. And that's going to be all in like the material properties of the things colliding.
Mm. Well, and then so I guess if you account for like all the properties that we didn't account for, you could start to see a more preferred frame then.
Um, so I purposefully picked an example in which whatever these boxes were in my first example, they're made of something where they stick together. The reason I did that is because this is the simplest possible collision. The fact that they stick together means that after the collision, I only need to track the velocity of the whole thing afterwards. If they bounce off of each other, now I've got still two separate objects after the collision. We would still use the principles of energy and momentum to see what's going on. And it would still be the case that regardless of which perspective you took, the amount of energy and momentum transferred wouldn't depend on which object was originally moving. It would just be a much more complicated set of variables to keep track of for like a late night purpose like this if I had to deal with the box of mass 2 ricocheting back off of the box of mass 8. Like I was keeping it simple by having the two stick together rather than having one of them like rebound
Right.
off the other, in which case we'd actually then have to know like
Right. Well, like
how
in
much.
reality, wouldn't we have to like okay, say like a wrecking ball smashes into a ping pong ball? We would have to look at both of the remaining masses after the collision, right?
Yeah,
To get
you'd have to. So the example I gave was what's called inelastic, which is it was maximally inelastic, meaning that the two of them stick together, meaning that there's no bounce back whatsoever. If there is a bounce back, then it means that after the collision, instead of having one singular big object that's now all moving together as a lump, you've got to deal with both pieces of it. It's still the same formulas. It's still the same formula for energy and momentum. It's just going to be a longer and more complicated a set of calculations to do um, between the two of them. It's actually it's doable, but it's significantly more complicated to do to run through the calculations when we have to deal with a bounce back and then a separation of the two objects post collision, like two cue balls colliding with each other.
right.
After
But
all that
well, even
extra work,
oh
there's
well,
never been anything observed that uh,
it didn't
would
match.
lead anybody to indicate that it would reveal that the assumptions of the simple case weren't accurate. It's just that's harder to get there.
Yeah, we could. I mean, it's just it would just take longer. But the conclusion is the same. It's that the amount of momentum transferred is going to be the same regardless of what perspective you take. Because the point is this: the rules that are determining how much momentum that gets transferred are these rules about energy and momentum. Regardless of how the collision happens, it's the same rules about energy and momentum. It's sort of like having one object bounce off the other is adding in the same type of complexity as having them shatter when they collide, right? Like I just, for practical purposes of talking about this with people late at night, didn't want to have many separate objects coming out of the collision, all of which had their own energies and momentums that have to start calculating here. I wanted them to stick together, so I only had one thing to look at the end. Like every extra piece that comes off of the collision makes the math like many times more complicated to go through. I can do it by hand because I've been trained in this with a single elastic with a collision where they just bounce back from each other. The moment we even get into like shattering or like multiple pieces coming off, I'm like, no, screw it, go to the computer simulation. Like I'm not doing this by hand. I'm gonna be up all night. It's kind of amazing how quickly the complexity grows the more pieces you have coming out of the collision.
So okay, but so to check your math, like in reality, we'd have to check the remaining masses.
If they bounce off of each other.
Well, if they stuck to, well, I guess if you assume they stick together, you assume all the masses are stuck together.
Yeah. I was assuming that all the mass sticks together, that no piece of the mass bounces back, breaks off, anything like that. That's why I sort of said like, okay, total mass of 10. I've assumed a perfect sticking of the 2 to the 8 where no physical piece of the mass goes off anywhere else at the end. And you can do this. Like if you have like, two hockey pucks and you just put like a little Velcro on them so they definitely stick together. That's a way of creating this. Or like a bullet that lodges into like a big block of clay. That's a great one. If you have a big block of clay, but like on a track like with wheels or something that it can slide, and you fire a bullet into the block of clay, and it just goes in, and the clay captures the bullet. Right? You only have one object to deal with after the collision, which is the clay with the bullet inside. So that's kind of like a perfect recreation of what I did here. Assuming the bullet doesn't blast the clay apart, I guess. So you know what? Probably better to do it with like hockey pucks and like Velcro or magnets or something so that they just like stick.
What you said about the energy before the expansion, you referred to it as just a number. That they just added a number for dark energy.
Yes. Dark energy is a kind of band-aid number. It is that so the observation is the red shift of the light of the galaxies, right? So if you want to say what has actually been seen, it is that the light coming off of galaxies is red. And if you say that the reason it's red is basically a Doppler shift, then you can calculate how quickly the galaxies must be moving away from us. And the way that they first found to explain that was to just insert one extra number into Einstein's theory of gravity that they called the dark energy, and they found that putting an extra number into the equation basically would cause the effect of having distant things move away from each other in this way.
Yeah, but it's more than just a number, right?
Well, so that doesn't offer any causal explanation of it, right? So that's why I called it a band-aid number, right? It's something they're inserting into the theory of gravity by hand, right? It didn't come from anywhere. It's just saying like, okay, is there a way to model, to simulate galaxies?
Is there a way to bring something up out of our rear end so it can conform to our predictions?
Yes.
Which we previously
and then the
got
question
wrong.
goes, okay.
Just like dark energy, right?
Right. That it is dark energy, yeah. And then the next question is, okay, so how do you explain this? What's the actual physical process that gives rise to it? It's kind of like the status of dark energy is sort of like the status of what temperature was when the only thing people knew about temperature was the number on the thermometer. Like before they had any ability to explain what was causing something to be hot or cold. And like they were just like, okay, the thermometer goes up and the thermometer goes down. That's what I mean by it just being a number. So dark energy is a number that lacks any deeper causal explanation. An attempt to provide a causal explanation is the concept of vacuum energy, but it's a dramatically failed attempt. In that nobody
they just basically made it up. Like when they said nothing travels faster than light, right? Then they noticed, and I'm not saying I believe this, I'm just repeating the pseudo model. Then they noticed this expansion that you're referring to, the redshift, and it's expanding faster than the speed of light. And do you know the band they came up with full?
It's a little funky how they get to that claim because
a little.
yeah, well, to be clear, we're not directly observing anything that's expanding faster than light, but they're taking the fact that galaxies are moving away from us and seeing the trend that the further away they are from us, the faster away they're moving, and sort of extrapolating that out. That if the expansion effect gets larger and larger and larger the further out you look, eventually, hypothetically, you'd reach a place so far away from us that the expansion effect would have things be moving at faster than the speed of light, right? So it's not a
Right,
direct
which is not possible according to Einstein, right?
Um, so the reason that they say that this is okay is because it's not an object moving through space, it's the space expanding. That it's a different.
There you go. So you finally came around to it. Exactly. So that's the nonsense they came up with. They can never admit they're wrong, right? They can't just say, no, we got this wrong. We witnessed something traveling faster than the speed of light, but they just can't bring themselves to admit they're wrong. So what did they do? Well, they made a workaround, a band-aid. It's actually the space that's expanding faster. It's like it's so pathetic, bro. So pathetic. Yeah.
Well, they're trying things. I mean, you hear that I have my own criticisms of all of this. Um,
Look, all
certainly.
three things, right? Dark matter, dark energy, traveling faster than the speed of light. They just can't bring themselves to admit they got it wrong. It's incredible, but I know this is the state of cosmology we're in today.
Well, I will just give my own personal opinion on it. I study this stuff. I have my own thoughts. This is not confirmed science. This is the thing I'm interested in, as I am interested in, and I do my research into alternative theories of gravity, precisely because I am very bothered and skeptical of where the physics community has ended up at this point. So I've pulled back far from that, and I'm looking into alternative theories of gravity, where
Like
it gets
what?
me the
I'm
phenomenon
interested.
of gravity.
Like what?
There is a particular model of gravity, a particular theory of gravity that goes by the name conformal gravity. I'll type it out in the chat.
Sounds interesting.
Yeah, can
I
you give
feel
us
Wait. Can I? Is it bending and warping concepts?
yeah, it's still in that, but it's different. I mean, you can still interpret it in that way, but there's a lot of other things about it that I would say are pretty qualitatively different. Um, it is like you let me just give a sort of a side note here to the whole bending and warping thing, right? Um, like we see when you throw an object that it follows an arc to the ground. So there is a particular way to think of the bending and warping of space that's going to make it seem way more mundane and way less extraordinary of a claim, which is simply that we can choose a coordinate system that is not straight parallel lines, but instead is curved lines that follow the natural paths that objects take while they are falling, right? We could get more philosophical about like what is space, or anything like that. But when you ask me like, is there bending or warping of space? Um, on some level, I would say yes, but I would point out that perhaps all we actually have to mean by that is just that the behavior of objects due to a force of gravity is such that we can pick a coordinate system of curved lines that neatly maps onto the motion of the objects. What I would say, though, is that we need a clear understanding of what the phenomenon of gravity is. So I think that it gets it backwards to say that space warps, therefore that creates the phenomenon of gravity. What I would say is that we need to understand the phenomenon of gravity in the same way that we understand things like electromagnetism and the nuclear forces. And then after that, if it turns out that you could make the picture of objects moving due to gravitational influence and fit it to a visualization of warped lines in space, great, bonus, perfectly nice. I'm comfortable with that as being a visualization that comes out the end. I'm not comfortable with that as being an assumption that goes into the beginning. I hope that distinction makes sense. So one of the things that is interesting to me about conformal gravity is that while you certainly could still take the end result of it and visualize it in the language of the warping lines of space, it does start at a different set of initial assumptions about the nature of gravity. And it is a theory in which the phenomenon of gravity is much more closely related to electromagnetism and the nuclear forces than is the present
Oh,
situation in Einstein's theory.
So
nice.
what does that exactly mean? Like, what do you mean? Like,
Well,
can you be more specific?
yeah, I'm going to try to give sort of a conceptual overview of it. So I'm trying to think of the best way, of talking about this. So,
What's the mechanism? Plain and
right.
simple.
Well,
What's yeah?
it's a field like the way that the electric field and the magnetic fields are fields. And I'd also point out that our understanding of what the fields are can get pretty hazy if you were to ask, like, philosophically, like what does it mean that there is an electric field that comes off of a charged particle? But the point is that whatever the fields are, like the electric and the magnetic field, they they have certain fundamental properties that are very important to how they work. And those properties are, at least some of them, are notably missing from Einstein's equations of gravity. So one of the points of conformal gravity is to reset the assumptions of how gravity works and make sure to incorporate all of what I would consider to be the most essential properties that are also found within the nuclear forces and electromagnetism. Though, whereas the nuclear forces and electromagnetism target charge, they act directly on matter because of the charge value of matter, this is targeting the mass value of matter. In a sense, it brings the concept of mass much more closely in line with what the concept of charge was. So charge produces electric field, mass produces gravitational field, but it makes the mechanism of that much more closely comparable and related to the key properties of how electromagnetism works. So I know I'm giving sort of a very broad overview of the
No,
whole
but
thing, but
what I'm hearing is you're just basically saying it's electromagnetism.
it's not
Yeah,
identical to
so
it, but it reincorporates it reincorporates for mass what I and the other people who are working on the theory believe are the key properties of electromagnetism that makes electromagnetism work,
and
that were left out in Einstein's considerations of gravity. It's a different set of initial assumptions about how mass affects mass across distance, and you call that phenomenon gravity.
when you say
To
nuclear forces, those are electrostatic, right?
They're highly similar to it. I mean, they're
Okay.
not identical to it, but they're highly similar to it.
Okay.
Um,
You're just sounding like a flat earther almost.
well, I think that the key beliefs of flat earthers are that the Earth is flat. But
I don't know how
uh,
they explain gravity,
well, the
density and
problem.
buoyancy, and the directional biases set by electrostatics.
Well, I mean, the problem with how they go about this is that they're trying to say that gravity is literally just the electrostatic force, not that it's something
No,
similar or analogous to it, but that there's literally no distinction between gravity and the electrostatic force. So that's not what I'm
no,
saying.
they don't claim electrostatics is like holding us onto the Earth. They just claim that it sets the directional bias. So, like in a circuit, we have was it amperage up and then wattage down back to the ground.
Yeah.
Yeah, so that directional bias is set by the current, the natural current of Earth, and then density and buoyancy handles the rest.
Well, all I'd say to that at the moment is that if you have an object, we can independently look at its mass and its charge. Like if I've got a metal ball, I can add charge to it with a wire. I could take charge off of it by grounding it. I could add mass to it pretty simply, put a clump of clay on it or something like that. I could take mass off of it. Like charge and mass are independent quantities from each other. I can separately manipulate how much charge an object has from how heavy it is. So, I'm not going to work on a model in which mass and charge are literally the same thing because at a very basic observation, I can say that they're not literally the same thing. But I do think that they are more analogous, or that we've maybe missed the idea that we could be treating mass in a way that is more similar to how we think about charge. Um, so yeah, I'm trying to think about kind of what else I could say about sort of the implications of the difference in this model compared to other models. But one of the main implications of it is that some of the key properties that get reincorporated into the phenomenon of gravity within this model, in making it more similar to electromagnetism and the nuclear force, makes gravity a long range effect in the way that it isn't within Einstein's theory of gravity. So if you notice when we talk about things like Newton's bucket, right, and the question of like what provides the basis for absolute rotation and stuff like that, if all frames are meant to be relative, this theory very much diverges from Einstein's theory at the large scales about what it's saying about the relativity of motion. I don't know if it would be exactly appropriate to say that it restores an absolute frame. I think in the way that most people here would hear that and imagine it, but uh, it does posit that that all the matter within the universe is affecting all the matter within the universe in a much more tight way than you would get in Einstein's theory, and beyond resolving a lot of little things, I hope, about things like dark matter and stuff like that, it also provides a much greater clarity of like what the basis for a preferred reference frame is, what the basis for absolute rotation is.
Well,
Right, because
wouldn't
one of the yeah, sorry, on.
no, I don't. I'll finish off. I just want to ask you a question
What I
after.
was going to say is like one of the logical problems within Einstein's theory of relativity is that all motion, right, is supposed to be completely relative. That but then you've got the question of like Newton's bucket, right, which seems to show that there is some absolute standard of rotation. Well, if there's an absolute standard of rotation, what is the bucket rotating with respect to? Well, that's where Mach says, oh, it's rotating with respect to the rest of the universe. But that's not a causal explanation in Einstein's theory because there's no influences of force that extend out from the bucket to the rest of the universe. So just saying that the rest of the universe provides a preferred reference frame from which you could look at absolute rotation lacks any actual causal explanation. This is one thing that Einstein in his own work was very disturbed by. He recognized that this was a major kind of conceptual problem he didn't know the resolution for within his theory. And one of the things you get from a theory that changes the nature of gravity such that there is basically a permanent residual long range influence tying every object of mass to every other object of mass within the universe is that you now have the causal mechanism that Mach was looking for. You now actually have a causal explanation for why it is the case that Newton's bucket knows it's rotating with respect to the rest of the universe.
Which is what? What's the causal?
This gravitational influence, this interconnectedness, the fact that I don't know exactly what the right analogy would be, but like almost if you imagine that like each object in the universe is tethered to all other objects, if you try to spin, you're twisting the tethers. It's a loose visual analogy. But the point being is that if there is a force that is persistent over long distances, then objects do feel the influence of the rest of the universe on them. Maybe not
That would.
most
Let me
immediate
interrupt
way.
you before I forget this, because then that would be a preferred, an absolute frame of reference, right? If that's the
Yeah,
case.
I mean,
Well,
I
then,
think you
okay,
could.
hold on. But then that would destroy relativity, would it not?
It curtails it. It curtails it in a significant way. It doesn't destroy the idea that local observations, it could be irrelevant between different frames of motion in like the collision example. Like none of this is going to change everything I went through with the collision example where I was saying that specifically a pressure plate at the moment of collision between two things cannot use that data point of the collision to decide which one was moving. But it does establish that the entirety of the mass of the universe is unified together into yeah, I guess what you would call a preferred reference frame at the largest scales. So
Right, but
you know,
that goes totally against relativity,
and
because
this is
there is
not
no
general.
absolute reference frame. Everything is relative to everything else, right?
Yeah, and this theory is not general relativity. It's a different theory. It's still compatible with a more qualified version of relativity, right? It's still compatible with certain ideas like the collision example and other ideas we could get into, but it is selecting out a background reference frame of a sort when you zoom out to the cosmological scale, because what it's saying is that all the matter within the universe is under maybe a subtle on the scale of human beings, but a very real kind of constraining influence from all of the other matter throughout the rest of the universe. So anyway, that's one of the things I find so interesting about the theory. And by the way,
Is that your theory? Or
it's
the
not my
one that
theory.
you're going with?
No, it's not something I came up with, but it's something I'm researching. It's something I'm researching because I find it interesting. And by the way, this long-term influence, this thing that exists within conformal gravity that does not exist within general relativity, that is this universal influence of matter on matter at all distances. Not very strong, right? Like it's not something that we're expecting to feel as just like you're a human being walking around, right? But is present. That is extremely mathematically similar to the nuclear forces that bind together things like the proton and the neutron. So that's what I meant by this reincorporating into gravity some essential features that are present in electromagnetism, but in a sense, even more importantly, in the nuclear forces than electromagnetism, that is not found within general relativity.
Those are at the micro scale, though. I think
Yes,
you mentioned that
this is at the
this
macro scale.
works at
Yes,
long distance, right? You're
yes, very much so.
so what would be the causal thing in that long distance? Because it cannot be at the what works at the micro scale, right? So
right, it's not the
what are you talking about
same
here?
thing as the
Are you
nuclear
proposing an
force.
ether, a background medium? Everything's
It's not the same.
connected.
Well, I've already been comfortable with just saying that I think that the fields of physics, um, I don't really like when I go back and like in my physics courses they were like, oh, the ether is dead, we now have fields. But then when I actually
Mhm.
read what ancient philosophers had to say about the ether, like I'm fairly sure that Aristotle, I'm just guessing, would say that the electromagnetic field is ether. Like, I can't ask Aristotle, but I have to guess that. So there's a narrative in physics of like, oh, we got rid of the ether and we replaced it by these things like the electromagnetic field, like the nuclear field. And I feel like the word choice of ether is already perfectly fine when it comes to that. It doesn't make a big difference to me on that point. Um, so yeah, so in analogy, not the nuclear force specifically, but in analogy to how all the protons and neutrons within the nucleus of an atom feel all the other protons and neutrons within the nucleus of the atom, this theory very radically would say that all of the galaxies within all the matter within the universe is tied in this long range force to all the other matter within the universe, and that has some really interesting implications about there being a preferred cosmological reference frame. You know,
Yeah, because like to me, just the layman's ears, it sounds like you're proposing a background medium so they can transfer these forces and an absolute reference frame.
um, yeah, I mean, I don't know. I'd sort of say that the concept of fields already is sort of like a concept of a medium. I mean, the thing about the Michelson-Morley experiment and the topic of ether is it was really there was something very specific they were looking for, which was an ether wind. And I know you guys
Mhm.
debate that a lot, and they didn't find it, but like um okay, so there's no ether wind, or it's not, that's not how it works, right? Like I like the idea that there was supposed to be an ether wind and they didn't find it, I think came from them making the concept of ether a little too literal to the way that like familiar fluids like water works. um like I think historically what happened was in the 1800s, the concept of the ether became overly modeled on fluids like water. So they were expecting to literally see certain properties in the ether that would be like exactly like if you were a boat sailing through water, and they didn't see that, so they abandoned the concept completely. But that to me was silly. Like I think that they just were imposing on ether a property that they didn't really have any good reason to think that it should have, and kind of tangled themselves up in a, I don't know, in a
So
weird
so you
position.
think the interferometer wasn't the right tool to test it? Because
Well, I
from
don't
what I
think that
read,
this.
they all agreed it was like precise enough. It should have been conclusive.
No, I just mean that the thing that they were testing for, okay, you're not going to see an ether wind, so the ether doesn't have exactly the properties that you thought it had. I'm just saying that I don't think that the word ether or the concept needed to be thrown out completely. I think they needed to adjust to their understanding of what its properties were. Just because you can't detect a wind as you move through it doesn't mean that the entire concept needed to be thrown out.
Or you're not moving through it at
Well,
30
I mean,
kilometers a second
so
or
so so
whatever
what's
the
interesting.
period.
Right. So what's interesting is you're in the position, I can tell that uh, because you have an interest in the conclusion being that we weren't moving at all, to say that if we were moving through it, we would have detected a wind, but since we're not moving through it, we don't detect a wind. And what I'm
Mhm.
saying is that I think that that was like not the right conceptualization of it altogether, and that they're just it's not something that causes drag against matter within that way. So it doesn't matter how you're moving through it, you're not going to detect a drag on light within it in that way. There's other ways of explaining the propagation of light, there's other ways of explaining the observations of light, and we can sort of re-explore what the idea of ether is here without it having the properties that you would have like a drag effect. Like it's like they thought that the ether was something where like if you're driving in your car and you stick your hand out the window, you feel the air rushing by. Like they were looking for something like that, and they didn't find it. So okay, maybe that means you're not moving, or maybe that means you just fundamentally misunderstood what the actual detectable properties were supposed to be
What's
of.
your alternative theory for the propagation of light? Like they say it actually moves from A to B. Is there another way to explain it?
The propagation of light. Are you saying, why the speed of the interferometer doesn't detect something like that? I mean, really, so you're asking the question of why would it be the case that light will look the same in its speed to an observer, regardless of how fast the observer is moving? Is that a fair?
Well, yeah, and we only have have we measured the two-way speed of light or the one-way speed of light? Because that's another issue as well. And when you're talking about like what I was just thinking is that if you could have two different dimensions and you're talking about one dimension as the ether causing drag, and if it's not causing drag, then how are you going to measure it? Well, we have lots of examples of another dimension within our own dimension which is not detectable besides perception.
Uh,
And perception is
So
hard to measure.
if we have this amount of perception, we would have infinite dimensions, wouldn't we?
We
so,
do, right?
yeah, so we've only ever detected the two-way speed of light. We've never detected the one-way speed of light. Um, just that fact alone leads me to be very cautious and sort of interpreting any claims that anyone is making about the nature of the speed of light, because if you look carefully at basically any argument anyone's making on any side about the properties of light, they're often making arguments about what they think the one-way speed of light should be when all we experimentally know is the two-way speed of light. That'll be sort of the first comment I'd make on that. I'm not sure it's possible to measure the one-way speed of light. Now, as far as why observers, regardless of how they're moving, might all come to the same conclusions about what they think the two-way speed of light is, um, I I'm fine with the conclusion that the observer's velocity does not change what their measured value of the two-way speed of light is. I'm not fine with putting this as a postulate. And you should know that there are physicists who reject that postulate from Einstein. I recently was listening to a talk on it at a conference, right? So the controversial postulate of Einstein's theory of relativity is to say, as a matter of axiom, as a matter of assumption about reality, that all observers, no matter how they're moving, will measure the same speed of light. And definitely most physicists accept that. I don't like that. I'm skeptical of it. I think that that is a wild postulate to make, because something being a postulate means you're not going to actually have to prove it to be true. Like, you're just going to say that that is your starting assumption that you build a theory of reality around. There's another perspective that says, even if it is the case experimentally that your speed will not change what you would measure to be the two-way speed of light, that might be a conclusion that is output from a proper theory of understanding, like how the matter that is measuring the speed of light is reacting with the light, and how moving is affecting the forces that are, determining the behavior of that matter. In a way that you might end up with the conclusion that just because you're moving very fast doesn't mean you would measure a different two-way speed of light, but it's a conclusion that comes from a mechanical explanation of the workings of the electromagnetic forces inside the measuring device that is moving and is trying to measure the speed of light at the same time. So you don't need to, or you never should have made a constant speed of light to all observers a axiomatic assumption. Like, if you can get it out as an end conclusion of a rigorous analysis of how the measuring device is actually detecting the speed of light and how the measuring device works based on the internal electromagnetic forces of the device, that's okay. And that's a cool conclusion to reach, but it shouldn't have been a fundamental assumption of the model. It's at most a conditional conclusion based on a thorough analysis of the forces in the matter of the detector of the light source itself.
Interesting.
So
What are your? I don't know if like are you still going to stay on topic for a while, or what's the plan?
I'm a little sleepy, but it's been a lot of fun. I do worry that might have come across, because I am getting a little sleepy, as maybe a bit rambly. So if I could try to just maybe say that in a cleaner way, um, yeah, the position I'm
Or you
taking
just keep.
here is that it was not justified to assert as a first principle that all observers are going to see the same speed of light no matter how they're moving. If it is the case that it's true experimentally that all observers will see the speed of light no matter how they're moving, then that actually has to be demonstrated meticulously by looking at the actual process of like how a light detector, maybe the human eye, but maybe something much simpler, whatever, that we're using to measure it, actually physically absorbs energy from the light to detect the passage of the light and how those forces play out. So I hope that's a cleaner.
I got like a lot of questions, but I was gonna ask, is there a test? Can we experimentally test this conformal gravity, like how they have Cavendish? Can we set something up like that, or?
I very much wish, and I've asked my mentor in graduate school, who's the one who introduced me to the theory, if there was an Earth-based thing we could do, and none that he could think of, and none that I could think of, because the effects of these this sort of long range property of gravity is very small. To give a sense of it, if you were to plot the force of gravity in this theory versus other theories of gravity like Newton's or Einstein. I know they say Einstein's theory isn't a force, but just whatever, it's an attraction. And you were to plot that, the two curves would start off the same and then they would later diverge from each other. So it's approximately going to look like what Einstein thought gravity should behave like when objects are close-ish to each other, and then behave differently from that when objects are much further away from each other. So we wouldn't expect there to be a testable difference at the sizes of something like a Cavendish or the solar system or anything like that. Where we would expect they would be different would be at way larger sizes. And that is directly where this theory presents itself as an alternative to dark matter, to dark energy. There's no dark matter within the theory. There isn't dark energy within the theory either. The point of this was to look for something that maybe could explain observations without requiring those extra layers of bandages. And I don't know, it's had a lot of observational successes so far, particularly in looking at the observed velocities of stars and galaxies. But the big question is the cosmic background radiation. That's the big question right now is what does this theory say about what we should expect to see in the cosmic background radiation? So ties back into that interest of mine.
Do we have any evidence for the attraction that you were just mentioning with gravity, like mass attracting mass? Is there like a concrete experiment that proves this?
Mass attracting mass. I mean, I'd point you back to the Cavendish. I know that people have issues with that one, but that's the only thing I could think of on an Earth-based thing. And this theory is not going to predict anything different for Cavendish than you would get from Einstein or Newton, because it's at such a the difference between this so there are foundational differences, there's assumption differences, there are ontological differences between this theory and the standard theory of gravity, but in practice they predict the same level of attraction between mass and mass at any sort of reasonable small range of distance between them, and only predicts a different level of attraction at essentially like universal sizes once you zoom way out to the whole cosmos. So as far as a proof of mass attracting mass, I don't know, Cavendish, I don't have anything better than that.
So make the same prediction on Earth as Cavendish, pretty much.
Yes, it does make the same prediction. It offers a different explanation at a fundamental level, but it's going to make the same prediction.
It just handles some of the larger scale problems.
Well, that's the hope. And I do want to be cautious in saying that if you go down the rabbit hole, you can see that there are just endless numbers of alternative theories. Like, I'm not the only one who's got an issue with the mainstream theory here. There's so many different alternative theories out there, and I'm not going to claim that this is anything other than something that I personally found interesting and decided I wanted to look into further and understand it more.
Do you know the flat Earth objection to Cavendish?
I
or
don't
the
know.
typical.
What's the typical objection?
Well, I mean, they didn't isolate the cause like gravity, right? And they never will be able to, because the molecular bonds, like the nuclear forces, those are electrostatic in nature, right? So you can't isolate those from two objects, right? Because they try to.
What if they fly away in a spaceship?
I don't know.
Yeah, they try to put it in like a Faraday cage, or fill it with inert gases, but
Just say like
they
on
can
a spaceship?
never. A spaceship?
Just say they could put it on a spaceship and fly it away? That
I
would
don't know.
isolate. That would be the removal of gravity, then, right?
Oh,
We just need a Cavendish on a satellite. No, on a. How far out do you got to go for no gravity? Real far, right? You'll never
yeah,
get back to where
I'm
you
not
were.
sure.
I don't mean to distract.
Yeah, so that's pretty much the main objection is you
Yeah,
can't you can never isolate the cause.
that they didn't isolate that it wasn't being interfered with by electrical forces and stuff like that.
Right.
I did the Cavendish myself once when I was a student. It's been quite a long time with the hanging masses and stuff.
Did you do the fountain version or the spherical pair?
No, I did the metal sphere one, and we didn't shield it, and we tied a laser pointer like to the rod that's meant to rotate, so we could see where the laser dot moved on the back wall. And
If you didn't
I wasn't
shield
a
it,
very
what,
good
what might be moving
experimentalist,
it then?
so
Well, I mean, the flat Earth explanation is pretty cool too, and you can test it. I mean, it just works with the density and buoyancy principles, and then
well,
the
not
electrostatics aren't like
Well,
gluing you to the ground. It's just setting the direction, the down direction.
Well, I
So
didn't think that you were saying that buoyancy had to do with Cavendish, but that it was like a electrical attraction between the masses or something. I don't know.
if everything's
Oh.
rotating at 15 degrees per hour, turning, yeah, isn't that?
Theory they have with density and buoyancy is that the vector direction of down is determined by an electrostatic force, and gravity is not there at all. So the little g is just a constant, and its direction is determined by electrostatics.
Welcome to the conversation.
Which is not the case.
Which is not the case, right? That's funny.
And I made the
But
point
yeah, that's pretty good, Steelman.
What I do know is that you can independently manipulate the charge and the mass of something, like the example of the metal ball. Well, I've made it very clear here that I do think that we've probably very much misunderstood gravity, and that we should be looking to things like electromagnetism to see what maybe has gone wrong in the structure of the theory of gravity. If anyone's claiming that the attraction of mass to mass is literally the same thing as the attraction of charge to charge. I would just point out that, well, I can vary the amount of mass and the amount of charge within an object separately from each other. So I'm pretty sure mass and charge are independent quantities of each other.
So you're saying the electrostatic forces that are making up the matter itself are not consequential?
In the Cavendish experiment?
Yeah. Well, I mean, I don't know. They seem to do an awful lot to reduce the electromagnetic surface. Like, put in a Faraday cage, inert gases. So it seems like they're trying to negate that. They're trying their best to isolate the cause, but they can't really do it. But yeah, what do you think about the flat Earth gravity? Just density and the principles of density and buoyancy, and then just the directional bias set by the.
I mean, I am curious, like, is there disagreement between the flat Earth people who are saying it's density and buoyancy versus those who say it's electrostatic forces? I mean, these seem like very different explanations to me.
No, I don't think they're claiming that they're electrostatic forces. They're saying in the Cavendish experiment, you can't rule out electrostatic forces.
Right, in the Cavendish experiment. Okay.
Right. Yeah. But just as a general concept,
You mean that things fall down because dense things
well,
sink?
the direction they go. So, like, if you take a Van de Graaff generator and you have it on the normal polarity, things are going to stick to either the top or bottom plate. Let's say it just sticks to the top plate. Okay. But if you reverse the polarity of the plates and you turn it on, now they're going to stick to the bottom plate. So that's what we mean by the directional bias.
Okay.
Right. And then the principles of density and buoyancy just handles the rest.
Okay.
You can push
So,
back. I'm not an expert or anything, but I'll do
well,
my
I
best.
noticed that, to give an observation, I noticed that there's a lot of interest in the flat Earth community in the properties of basically the fluid effects of the atmosphere, the discussions of how density and buoyancy influence the falling of objects, the discussion of the refraction of light through the atmosphere, the discussion of how an atmosphere would or should work on a spinning Earth versus a stationary Earth. It seems a lot of times we're coming back to discussions about how the atmosphere as a fluid is influencing all of these different observations that we see. I mean, my understanding of buoyancy is that it's something that slows a fall. It's, it's not the reason why things fall, and it doesn't seem like you're saying that either. It seems like you're saying that you would say that things go down to the ground because of what you're calling an electrostatic force, and that the atmosphere's buoyancy is why heavier things fall faster and lighter things float up.
Right,
I mean,
objects interacting with their mediums. The
yeah, I understand.
electric angle is just setting the direction, so objects
Right.
kind of know where down is.
I mean, I'm not an atmospheric scientist. I don't study the fluid dynamics of an object moving through the atmosphere, but my basic understanding is that the atmosphere is an impedance towards something falling down, not a cause of it falling down. And I've heard somewhat different things from different flat earthers as to exactly what that is. I mean, sometimes they just say that, like, well, everything just naturally falls down and buoyancy sorts out, which things sink further. And okay, agree on that point, that buoyancy sorts out that denser things fall faster through the atmosphere and like lighter things lift up like that of a balloon.
Mhm.
But that's really the atmosphere modifying the motion of things. It's not saying why they would have a interest in falling down in the first place. And I've heard both from flat earthers that just, okay, that's just the natural tendency. They just like, it's just, this is just what things do. The earth is the floor and things go down, and they call it downity or something, and I'm not really sure why that's different than gravity at that level. And then it seems like there's kind of a second claim, which is that we can understand the direction of things going down by an electrostatic force. And that claim's interesting.
Yeah, there's no like there's no force. We're not claiming it's electrostatic, like pulling things down. It just sets the direction in which they go, right? If the polarities were reversed, um, they would go the opposite direction.
But sure, in the Van de Graaff case, yeah.
Right.
And
But
I think
when you look outside, we just have a natural current in the atmosphere, amperage up and wattage discharging down into the ground. So that
okay.
current, that path of that current, that's that directional bias that's being set. It's not pulling you down to the ground. Density and
like to get
buoyancy
your
are
buoyant,
going.
wouldn't your density and buoyancy just be based on the interaction between the material and that current or flow? So the denser the material, the more it interacts with that field, thus density and buoyancy.
Yeah, the object, how it interacts with that medium. Is it denser or lighter than the medium it's in?
Yeah,
The thing about
that's
buoyancy,
definitely
though, I'm sorry.
like a rock sinks in the water and a plank of wood floats up from the water. That certainly is how buoyancy works. I mean, I find it very complicated, and I'm not an expert in fluids, and the air is a fluid medium. So the thing I would ask about is, okay, let's make a vacuum. Let's pull a vacuum. Let's evacuate all the air out of a tube. Then we drop something within the tube, and it falls down. So now we get to see something falling in a vacuum tube in the absence of the air. Right. So now what is the explanation for what is attracting the object down to the ground? We've removed
Background
the air
medium.
There's
well,
a
not the air
current
we
flow
There's always a
versus
medium.
all material. Like a high enough voltage, that like there is no true insulator. Like just as people say in these rooms, there is no true vacuum. There's no such thing as a vacuum, right? There is no insulator. And then you've got a
there's
current
free
that
space
flies,
impedance.
just like courses through everything. And dependent upon the density of the object, it creates the dependency upon how much influence it has on that object. And so if you've got a lead ball in water, then yeah, the lead ball is going to be pulled to the bottom of the water because it's having more influence with that field.
The challenge is, though,
more interaction.
If we take one of the standard
I
buoyancy
guess what I'm trying to understand is if the claim here is that it's an interaction between matter and like the literal air that I'm breathing and feeling around me as I swish my hand in the air, which is why things fall down, or if a fluid medium is an analogy for like an ether-like substance that exists still within a vacuum of space when you pull the air out of it, which is why I brought up the example of the vacuum tube of sucking out all the air. There's nothing left to breathe in there. It's empty of matter, and you drop an object within it, and then the object goes down to the ground. So are we talking about this as saying, like, is this an ether theory where we're saying that objects are falling because of their interaction with the ether, which we can sort of analogize to a fluid? Or is it what we're saying here is that objects fall to the ground because of their interaction with the literal air that I'm breathing in right this moment?
Yeah, I don't know why they convolute it so much. It's pretty simple. There's a current traveling from the sky down to the ground. It traverses everything. There's no true insulator, so it passes through everything. The interaction is dependent on the density of the material it's coursing through, just like a sailboat, for example, on the sea. And then what was the last thing? The other curious aspect is I can't remember the name of the formula specifically, but the formula for gravity or something is basically it parallels or looks exactly like the electrical formula, which is just kind of curious. I'll land there. I know a couple other people wanted to get in.
And that's my interest in gravity is pursuing that comparisons between gravity and the electric force may not be coincidence, but that we may be missing ways in which the gravitational interaction is much more within the family of something like the electric force than was previously understood. But to be clear, in your explanation here, right, it still works within a vacuum tube. You're saying this downward current that's why objects go to the ground, doesn't depend on the object being in air, that this still works even if we put it in a tube and we suck the air out of the tube, it'll still go down because of this current.
Just take their terminology of air and just say space, an object in space, which there is no such thing as an object not in space. I don't mean the space up there. I don't know why they the linguistics or the language or description of this shit gets so convoluted, but for whatever reason it does.
But so no, I like how you laid it out the first time, Rick. There's a current down to the ground that sets the directional bias, and the object, its relationship to the medium that it's in, is how it's gonna interact.
Yeah, and then if you want to, like, if they sort of beg of you, oh, prove it, detect it. We can detect electrical forces all day long. The trick is you can't actually detect an electrical force unless you've got its neutral. You need to have a neutral in order to perform any what are they called? I was about to call it a millimeter. What are those frigging things called? Just your electrical DC detection, AC for that matter as well. But voltmeter, I was thinking of another term for it, like the fluke or whatever. Yeah, you need to have a neutral. If you go and test a 12-volt system and put it up against a inline, because I've done a little bit of electrical work and I had 12 volts sitting right to 24 volts. If you use that 12-volt line, connect your neutral to that and go to your 24, you're going to see 12 volts. It's going to look like a 12-volt circuit. And then the question is, okay, well, so how do we detect this electrical flow? We have to get outside the system. And I don't know, you guys can rack your brains over that one at that point.
The thing about buoyancy and this vector, right, is if you take the classic buoyancy stack, fluids of different density, how they separate based on their density and gravity. If you accelerate that stack of fluids, you can do two things. You can shift the direction that buoyancy will act, and secondly, you can change the force of buoyancy. So the force of buoyancy is dependent on acceleration as well as the difference in density. So you can actually create higher density gradients. You can change the direction of density of buoyancy, or you can stop buoyancy working altogether. And which shows that it can't be the electric field that is present.
Is this when you say that you drop something, or how are you stopping buoyancy?
Yeah. So if you get a tube full of different fluids of different densities, how they separate out based on their density. If you rotate that tube or accelerate it in other ways, you can determine the direction that those things will stack based on the acceleration that tube is experiencing. So in gravity,
like a centrifugal field,
gravity, which causes one direction. Yeah. But if you spin it or drop it, you change that acceleration that fluid experiences, and that changes the way that buoyancy operates.
How does it change the way that buoyancy operates? You're just going in line with the flow.
So if you spin it in one direction, you can completely reverse the direction of buoyancy, right? The buoyancy always aligns perpendicular to the acceleration vector that the fluids experience.
Doesn't this have implications for rotating?
I think I may need to go get some sleep. I've been up way later than I was originally intending on it, but really deeply appreciate the conversations, especially the interest people showed in me talking about some of the stuff I've been working on. And it was just as sort of like a closing thought for the evening on all of this. Like, the experience I've had working in physics, but outside of the mainstream, like dominant views of things, is that just like when I go to a conference, I'm listening to all day just people with all sorts of ideas they have, just all sorts of wacky theories, and like probably most of them aren't true, and they could be looking at the thing I'm working at and being like, there's no way that's going to work out. I don't know. I think the physics community as a whole is kind of lost, and that spawns a lot of interest in alternative models, both
And my
inside and
brother,
outside of
my
academia.
brother. And my name's Jamie Robert Hogg, man. Nice to meet you, man. And physics is not lost, man. We just have to take the shit over because there's a lot of bullshit thoughts going on. And physics is not lost, my friend. I got your back no matter what, man.
Okay.
That was fair.
Anyway, just because I'm not going to have time tonight to go through, I think, all of the things some people were asking me about regarding some of the specific stuff that's popular in the flat Earth community. I've heard a lot of different ideas, and I'm not sure I understand all of them by any means. But I very much, whether or not I think something is likely to be true, I enjoy this process of finding out what people are interested in and what they're thinking and stuff like that. So I know I'm getting very sleepy right now, but just wanted to say I appreciated the conversation, everyone.
I was gonna ask
Cheers, bud.
you for that for the model that you're
yeah.
the most
One last
interested in.
question.
Does it
Yeah.
treat gravity as a force? You just say yes or no.
Yeah, I'd say yes. I mean, I think that this
Okay.
is a bit of a philosophical distinction. Like, and this could just be like a whole long thing to go into anyway of like, what do we mean by force in the first place? I'm not sure the word force ever should have been abandoned. Um, Even in general relativity, that might be a separate matter. I think that might have confused things quite a bit. Like, I like
We could get
even
into it. Oh, my bad.
a
I was gonna
different
say
time.
we
No,
could get into it.
I want to do my best to answer before I go to bed, just to leave off with like kind of like a two-part response to that. First of all, one of which is that even taking Einstein's equation as given, I don't know if it needed to be pictured and conceptualized in the particular way that it has been pictured. Like, I'm not sure that you couldn't explain the predictions that you get out of Einstein's equation and still call it a force. That might be a separate matter. But I think more important to what you were asking me about the particular model of gravity that I'm interested in and whether or not I would call it a force, I would point out that my interest in this model is specifically because it is much more similar structurally in the mathematics to electromagnetism and the nuclear forces than Einstein's general relativity is. And if everyone's very comfortable calling the electromagnetic force a force, and I'm interested in an explanation of the gravitational phenomenon that is based on concepts much more similar to that, then I'd say, yeah, it's pretty appropriate to say I'm interested in bringing gravity back into a better alignment with the other forces. So that's probably the best I can answer on that at the moment.
That's cool.
All right.
That's cool.
Good night, dude.
So, dang, D-Mock, I thought you were gonna get in there. What?
Sorry.
Happened?
No, just because Daz's thing, I had a little ponder on it with his, but I think he implied that it was some form of rebuttal or something, and I'm just trying to get my head around it. I don't think it is necessarily, but I just need to make sure I'm checking, dotting my I's and crossing my T's. And what was it, like something in a tube with multiple ranges of density? If you accelerate it towards the ground faster than gravity, then it rearranges itself upside down, essentially.
Gaza. I mean, that's what it sounded like.
Yeah. So
Yeah,
the direction the buoyancy acts is based on the direction that the acceleration that the fluids experience is. So if you've got, so you've seen those images when the people talk about this buoyancy model.
I can work it out in my head, but maybe I have seen something here or there.
Like tubes full of coloured liquids all separated based on their density. You've probably seen those things in discussions around buoyancy. With those tubes, you can change the direction. So the theory you're talking about is that there's something electrostatic that causes down to be down, but we can make that buoyancy stack point any direction we like just by applying an acceleration in the right direction in the same electrical environment that you're discussing. So if we spin it around in a circle, you'd think that that electrostatic field must also be radiating because the buoyancy direction is also in that rotating direction. I'm trying to explain it in a way that makes sense, but yeah, you can show.
I'm struggling a little bit.
You can show that.
Excuse me, that was beautifully said, Dazza, and that was beautifully said. And continue, my friend. I got your back there. Beautifully said.
I got like a little cheer squad guy popping out. All right, okay, cool.
You can basically show that there is no electrostatic component to buoyancy.
Can you show that it doesn't have more effect on denser objects than lesser dense objects? Because I don't need to show density and buoyancy, which is why I think that the whole density and buoyancy thing is a non-contender in this. There is something that's superior to it. I actually don't ever really understood this buoyancy and density thing personally. I always thought you needed a force, and I thought the guys that just use buoyancy and density were rather like just missing the whole thrust of it. But I don't know.
We're rather dense. That's what you meant to say, Risky. We're rather dense.
Sure.
What force?
I should have made the joke. Yeah, dense people talking about dense things. Is that what you're trying to imply?
So Rick, you're saying density and buoyancy isn't really the main factor. It's the electrical force factor.
Yeah, because I mean, is gravity a force? Is the consequential aspect? Acceleration is a force. As I said before, that if you accelerate something down, you can get it to rearrange its stacking, and thus, I mean, what's the problem with calling gravity a force if gravity is not what they're saying? It's like what matter attracting matter that goes into when it collects so much it becomes a black hole or something into another dimension. I don't know about all that, but the idea that when I run electrical wires with enough current through them, or amps, they'll start vibrating. Electrokinetics or whatever it's called is it's pretty freaking obvious.
Yeah, but then at that point, my friend, you got to think like, shit. There's way more things above that. That's all we know. That's all you know.
How is
There
acceleration
must be
a
way more
force?
shit going on. Come on. Okay.
How is acceleration a force?
Is acceleration a force?
Yeah, you said
How is it a
acceleration is a force.
Well, I mean, you need a force to do it. Maybe that's a bad phrasing or something.
Yeah, completely. Because you can call something that isn't a force, just like gravity.
I'm looking up the terminology around it, unless you want to provide it for me.
I googled it. It said no, acceleration is not a force. In physics, they are distinct but directly related concepts. A force is a push or pull acting on an object. It is the cause of motion, and then acceleration is the rate at which an object's velocity changes.
So it's the explanation of the effect of a force upon an object. Then, so my bad. It's just it's the explanation of the effect that you observe on it, not the force itself.
That sounds better. What do you think, Elbow?
Yeah, I mean, acceleration is the effect.
You need a force to create acceleration or any form of change with vector. And then I just, what is it? I'm trying to get my head around this Dazza thing. And just because what you accelerate it down, the heavier object resists acceleration more than the other lighter objects, and therefore it rearranges itself and flips itself upside down under the affect of the force that you're putting down upon it, or the acceleration you put. I'm getting caught up in the linguistics.
Force is the cause, acceleration is the effect. That helps.
What? Can you name an actual force?
I can't. Can you name a force?
The police force. I don't know. Force of nature. I don't know. I feel like I should be able to. It's really obvious, or like the technical terminology of force is not like the one that they use in Star Wars or some shit.
Magnetic force.
Electromagnetic is a force.
Electro.
Oh, well, that was my appeal. That basically, like, this phenomenon we call gravity is a consequence of something electric. Which, I mean, I'm not breaking into my brain here. I don't think. Which it does it 10 times better than I can. Desert duck.
What's up, Matthew? What's up, guys?
Yo.
Matthew's often at his mic when he's in here. Thought I'd see if I could get him to come out of the woodwork.
Hey, how's it going?
How's it going?
Do you reckon the Higgs boson could just be sort of like the element of the atom, or the component of the atom which interacts with the electrical force that we call gravity?
I don't know. I read some about it when it was in the news, but I don't remember much about it. But I do think that he missed an opportunity. Like, they had this news conference, and they were announcing that they had finally measured the Higgs boson. And so there was a moment in time when all the newspaper and TV reporters went up to Dr. Higgs himself. And they said, "What do you think now that this has been discovered?" And he missed an opportunity. He should have said, "I told you so." And if he'd said that, that would have been the headline in every newspaper everywhere. But instead he said, "Well, it was a collaborative effort, and I'm so proud of blah, blah, blah." I mean, he said all the, I was like, no, you should have said, "I told you so," then say all the other stuff. So,
Well, you see, Matthew, like, if you don't know if you're going to get caught for a lie, you don't want to own the lie completely. You want to sort of, it's the terminology. How was that when you're found in, like, assisting a criminal? Oh, I can't remember that term. An accomplice. That's the one.
Yeah, but he was just predicting that the Higgs boson would be found eventually. So he could have just said, "I told you so."
No, definitely. I appreciate it. That would have been badass compared to what he did say. Take a little bit of credit if you think it's due to you, but I don't know. Sounds like they had to build a whole hadron collider, and yeah. So I suppose one should respect the fact that he sort of acknowledged everyone else. He could have probably done both. Been a bit of a,
He
like,
should have done
bit of a
both.
cheeky
That's
gun.
all I'm saying.
Yeah.
Were you listening to any of the festivities today, Matthew? Alan did an event, and then zzpop was in
No,
here. I think he's a team.
I went to something way cooler. I just got back from the New Zealand-Iran World Cup game here in Los Angeles.
Really?
Yeah.
And that's pretty funny. Like, what is it? The wokest country versus the I don't know, the whatever, the most conservative, Iran or some shit.
The Islamic Republic of Iran. That's what they called them. My team didn't lose, I'll say it that way. But guess what? Neither did the other team. It was a tie, 2-2.
No, it'd be fun. At least it wasn't nil-all. What, I mean,
Yeah,
actually,
it was
I mean,
cool to be there in person.
is it just me, or am I like, why is the US even allowing Iran to play in the tournament? Anyway,
I don't know.
That's bizarre.
All the sportsmen are sort of separate from the politicians, so I think it's okay.
They kicked the Russian. Well, they didn't kick the Russians out. They told them they weren't allowed to wear their national colors when it came to the Olympics. So I don't know.
Yeah, I don't know much about the history of all that.
Did you drink beer and eat hot dogs?
No, somebody near me ordered 2 beers, and they're the tall cans. And after tax and tip, I saw on the little machine that it was $47
For just two?
for just 2.
Yeah. Somehow that's not surprising, but $25 a beer. That's
Well, yeah,
crazy.
I mean, so the World Cup is a big, big deal in lots of countries, and so the people who are spending hundreds of dollars to fly to the U.S. and hundreds of dollars to buy a ticket and hotel and all that, what's $50 more, right?
Yep. And arenas often charge exorbitant amounts for the concessions, essentially. It's
Right.
always
I wasn't
more.
surprised.
Yeah. That's like 2026 more, though. World Cup and LA level prices, though, for a beer.
Right.
I feel like other places, like it still would be like 15, like double or something, or a little more than double, whatever it should be.
Yeah, 25 a beer is nuts.
It's like an $80 hot dog. Hot dog and nachos, $80.
So Alan already did his presentation. I thought it was tonight.
You're about 12 hours late. Not that much. Close.
Damn it.
Yeah, it was earlier. It was about stationary Earth, or is the Earth in motion?
Guess I will have to catch the recap.
You think there's any relationship to all these sports playing with balls, and then they tell us we're on a ball? It's like kicking balls around, living on balls. And then they push these sports so intensely that most of them have balls. I mean, obviously a ball is a shape that you would put into a hoop and kick around and it rolls and stuff, but do you think there's any connection
Yeah, we
there?
get balls in all sizes. You got tennis balls, you got footballs. Just as we got rings that are bigger and small.
Yeah. You mean like latitude
What
line
if it's
rings, you
smaller?
mean?
Yep, latitude rings. Exactly.
Yeah. What were you gonna say, Tarek?
I was thinking of some analogy to how cats will chase a piece of string or a light around to human beings. You put a ball in front of them, they can't take their eyes off it, like fixated or something. Captured.
Yeah, that's why I was just kind of I was thinking out loud. Like,
fail.
oh, sorry, what was the last part you were saying?
Well, that's why it became a ball, and then you've got ball, which is just such a fascinating sort of phonetic alignment. And then bread and circuses and the attachment of entertainment to this sort of modern society with all of its trappings, etc.
Yeah. Well, it's like they got us kicking around a ball with our feet while we're kicking around the ball in our minds that we live on a ball. I know that's kind of a stretch, but still, it's kind of an interesting. And then, like you're saying, yeah, the BAAL, like ball, that whole sort of androgynous being and everything that's related to that. I mean, obviously, games are fun, and you got like a puck in hockey, obviously, and a lot of sports have balls, though. Football is kind of an odd shaped one, kind of more of a cylindrical, kind of bullet shape, I guess. But I mean, maybe it's a stretch, but it does seem like sports are such a central part of, like, in my view, like the general programming, even though they are awesome too. They're fun. And I mean, athletes are incredibly skilled, and it is pretty amazing to watch them play and stuff. So I'm not really like into a lot of it, like in any regular way, but over my life, I mean, I've definitely enjoyed sports and things. So I'm not saying it's all bad, and it doesn't have to be related to the shape of the earth. The fact they tell us we're on a sphere, and there's all these games where there's, spheres being kicked around and thrown and everything. But I just kind of brought it up just to see what you guys thought of, if there is any connection there or not.
Yeah, if you look at Uranus, Look at the old city, Ur, and they put it in your ass.
Yeah, well, but I think like that Uranus comes from Uranos, which was like a god. So I don't really think it was connected to the word anus necessarily the way that it kind of is in the culture, I guess, because the way that I guess the translation ended up going from like Uranos to somehow, Uranus kind of thing, like spelled like I pronounce it Uranus, and so on. But Uranus and like, yeah, was that purposeful to go from like Uranos? Because Uranos originally, I don't really think it's related to that part of the body that I'm aware of. It's like a sky god.
Yeah, but the city Ur existed even in the Bible, so it is two separated words they put together.
Yeah, also the fact they say it's like sulfur rains on Uranus, as they would pronounce it. I've always just said it Uranus, but that seems like probably purposeful, if nothing else. Even if somehow the change of the spelling originally, whether that was purposeful or not.
Yeah, I'm purposefully calling it Uranus. I think it's a good joke.
So Matthew, this was at like a huge arena, I assume.
It was at SoFi Stadium, temporarily renamed Los Angeles Stadium because they don't want to use brand names. And it has the largest screen in the world.
It's bigger than the Sphere in Las Vegas.
That's a good question. Maybe that doesn't count as a screen. Maybe it's the largest stadium screen. I have to look.
Yeah, I could. Yeah, I wonder because that Sphere thing looks massive. I haven't been there, but heard quite a bit about it. And then the outside screen. But yeah, if you're saying like the biggest, either like stadium one or it's just like looks like it's like a huge flat screen, or is it one of those square ones?
No, it's circular kind of. It's the largest screen built for sports. That's what the internet says. It's like a big screen that kind of like hovers above the field and is circular, so everybody can see it.
Wait, so it's like a sphere shape? I'll have to go look it up. I might go. I'll go.
It's more no, it's like a flat ribbon.
What is the arena? I'm gonna look it up now.
SoFi Stadium, SoFi.
Oh wow, it's like that's crazy looking. Wow.
40 feet high.
That's why I had to look it up. Yeah, I don't think I would have really thought. It's almost like a headband, but massive. It's like the shape of what a headband would be, but huge. Wow.
Let's see, 40 feet and 160 feet wide.
Is that the first time you've seen this thing in person, or you've been there before?
Right. No, I've never been to the stadium before.
Was it
It's
impressive?
fairly
This thing
new.
looks crazy.
Oh yeah, it was like the most impressive thing about. Well, the whole thing is pretty interesting. Yeah. Also, the field level is something like 40 or 50 feet below ground level because the roof of the thing couldn't be too high because it's right under the approach path for LAX. It's like right next to LAX. So I thought
lower down.
I thought we were gonna have to climb way up high to get to our seats, but we walk in and I was like, oh, our seats below us, even though we had pretty good seats, but it's kind of cool.
Interesting. Yeah, you could tell you were like going down in elevation. Yeah. Well, it's like with Madison Square Garden in New York City, it's the opposite. It's like up on like multiple floors up. And when everyone's dancing, the whole thing literally is shaking. The whole it's like you're going up and down like several inches, as you're just standing still. Like that's how much the whole place is shaking. It's crazy when everyone's dancing. But yeah, because that's up on I don't know what floor, 7th floor or something. I'd have to look it up. But yeah.
But yeah, it made me want to go back again for some other events there sometime.
5th floor. I just looked it up. Madison Square Garden is on the 5th floor. Yeah, it's just weird because you're going up all these like flights of stairs or like escalator just to get up to your seats. But you're saying this one you go down to your seats. What were you saying? Oh, to go check it out someday. You're saying if I'm in the area, Or just like,
Yeah, but I'm also saying that I would want to go back again to see some other events there.
oh yeah. What? Yeah. What all do they have concerts and stuff there too?
I think so. Yeah, it looks like there's let's see. Oh, there's like 6 more matches there, including 3 more group ones, round of 32. Then the quarterfinals is there.
So this thing, like, you can see the inside and the outside. So you have to like pick where you put your eyes of what you're looking at, because you can see like it's like almost like a headband or like a circular thing like this. So like that's pretty. So like wherever your seats are, you're seeing. Basically, it's just like multiple screens on the inside and the outside of that thing.
Yeah, but they're showing the same thing. It's just so that different people can see it well.
Oh, like this image here I just found. It's all the same, kind of like that.
Yeah, kind of. I mean, yeah, it's just like this big wide thing, and they put several things up there.
What just Marvel of the modern era. I mean, I don't know if Marvel's even the right word. I'm kind of saying that in more of a critical way, I guess, because it's kind of awesome, but it's also just like media commercials, like, you know, accentuated and as this sort of like central almost worship thing, you know, like it depends on what window you look at it through, what lens, you know, like in one way it's amazing and incredible technology, and it's probably very like that sphere in Vegas looks incredible too. But on the other hand, I'm imagining just how many commercials for probably just like, in my view, probably like toxic products and companies and stuff that are just like hurting the world. And then just the media like overload, and then the kind of bread and circus thing of like the Greco-Roman kind of style of everybody come and drink and root for your team. You know, meanwhile, you're not really taking any action against, I'm not saying you, but just in general, all the distraction in the sports kind of, in my view, would make people easier to control, which is why they would do it. So it has kind of a dark like background to it in a way, in my view, or at least part of it. Do you agree with any of that? Like, do you think any of that's happening, or do you think it's just all good, or like, what is your view on it?
Well, I would say it's a screen like any other screen. You could ask the same question about televisions, right? Is television a good or a bad? Well, it kind of depends on what's on the screen. So, I would say that's the same for all of these different technologies. The internet, even AI. What is it trained on? This big screen. Yeah, it's impressive to look at. I didn't see anything sort of nefarious about being at this game. It seemed just sort of like a fun sports thing. So I don't know if I'd see anything deeper than that.
Yeah, no, I hear you. I mean, yeah, and it's all pretty like safe. Like no one's like in the, you know, the idea of like the Roman thing where they're like killing each other out there is pretty crazy. Whereas with this, like everyone's just generally safe and happy and whatnot. But I mean, do you think that if you were the controllers though, I mean, okay, do you think there are controllers basically? Like, do you think there, you know,
there are competing powerful people that compete to be in charge of different countries, and then sometimes they cooperate a little bit, but I would say that there's evil people are more likely to be against each other than to unite on a common cause.
What about like the CIA or the FBI?
I would say that there might even be factions within those organizations, but they generally have this. So yeah, that's an example where they would cooperate, but it's sort of like one entity.
What about like the mafia or the mobs or like different groups?
That's
like
a great example. So the mafia does kind of cooperate with other parts of the mafia somewhat, but obviously there are turf wars and drug wars and all this type of stuff, especially in Mexico. And so yeah, you might get some cooperation for a little bit, but ultimately each of them want their own family to win.
Yeah, well, it would come down to what level of coercion could be going on. So, like, you know about like the Nephilim, and I mean, you don't think there's any chance that there's like some, even, I know you believe in the Bible and all of that, but like, is there any even part of you that would consider that there is some kind of like supernatural level of like entities that are maybe not even human,
sure,
that could be involved?
And in fact, I do think that there are Satan and his demons do have some kind of like coordinated agenda. But I would say even them, because they're evil, I would say that there's probably rivalries among them.
Well, like, okay, so if we even take the Satan concept, if we roll with that, because that's where, like, I mean, there is some overlap in your mind's viewpoint, I think, even though I'm not claiming I know all of your views.
Yeah, no, for sure.
But there probably is some. So, like, even if we take the Satan or even just something like very evil like that, so if there is like a group of controllers of sorts, then that would mean that would be like, you know, potentially if they're evil too, that would be like, you know, if I just use the word Satan, that would be like Satan's like most prized, it's his best work right now, basically, of what he can do to humans. Get them working together to do evil, right, and lie and whatever else, and do crazy stuff. So that would be like, from the idea that there is like a Satan kind of thing, like the peak of what Satan is concocting right now. Now, if you don't go that far with it and say, well, no, the only grip Satan really has is like more kind of just in some individuals, individual humans, this guy is a psychopath, or that guy is hurting someone or killing people or whatever. And it's more kind of decentralized, if you will, so what do you think of that? Like, if you do think there's like a like Satan's force in this world, then what is the deepest part of the rabbit hole that you think Satan is doing right now and getting away with? Or do you not go that deep with it and say that it's just much more minimal and there isn't really like, because when I say the controllers, I guess partly, yeah, I am alluding to like more of a centralized group that, yeah, would, I mean, be connected to something like Satan or just, evil in that sense. So like what level do you think it's orchestrating right now?
That's a good question. My basic answer is I don't know, but I don't know. It does seem like there is some coordination, but it seems like anarchy and chaos is also a feature of Satan and his minions and demons, or whatever you want to call it. I don't see it as like a well-organized machine that they're all cooperating. I see it as more like a chaotic, like, power grab among themselves. Because remember, they're evil. They're not like working together is kind of a feature of goodness, and kind of rivalry and chaos is kind of a feature of evil. So I don't know. That's a long way of saying I don't know.
Yeah. Well, I mean, the orchestration thing, to me, there does seem to be a lot of criminal groups out there, and there's a lot of criminal people that get together. There does seem to be, in my view, quite a bit of orchestration, just even in gangs and things. But yeah, I mean, especially if you have billions of dollars as well and control, like these JP Morgan and these kinds of guys that seem to have kind of taken the reins of humanity. That's why you go down the street, and obviously one of the biggest banks is, these Chase and JP Morgan banks and all this. I mean, SoFi is a huge bank too, right? Who the stadium is funded by or whatever.
That I don't know. I guess I never thought about who SoFi is. I guess you're right. Yeah.
Yeah, it's like Social Finance Incorporated, I think is what it stands for.
Okay.
Although, yeah, I think they're different than maybe like a standard bank, but they are in the whole banking stuff. Yeah. So yeah, to what level of orchestration? I mean, I hear you, but what I was saying before, like I mentioned the Nephilim, but it doesn't even have to be Nephilim. But I mean, are you open to like that there could be an actual metaphysical, like maybe not even human? Because I mean, I hear like where you're coming from, and I think growing up, I had like certain times in my life where, yeah, like I just understood the world around me to the point to where whatever my views actually were, I could just also kind of, be aware of other people's views and kind of almost absorb it, just like almost like trying it on, being like, oh, that person sees it that way, which we all kind of do that probably. So like I hear what you're saying, and like I guess just thinking of humans as like we're just here. Yes, some people are meaner than others, some are evil, some are not, but overall we're all just humans here, and that's it, But then if you start to consider that there's like more orchestration that is actually going on, like are we all just, well, then there's the question of, are we all just humans just here, evolved on this ball or whatever? So like, are you open like to the idea that there, for example, could be like another species that is not human, and then they have kind of taken over the world, and then they might have a bunch of humans like brainwashed under them? Like, do you think Satan could actually be doing that through a different species, and then that species is then controlling a bunch of humans? Like, is that in the realm of what you think could be possible?
I would say that I think the Nephilim might have been some kind of weird mix of the sons of God and the sons of man, or humans and some kind of like somewhat supernatural beings, because it seems to be that that's what shows up in some of the Old Testament. But my impression is that those other kind of like natural supernatural beings have been bred out or aren't around anymore. So I think there's enough depravity in just plain old human beings that you could explain everything that's going on now with just regular human beings kind of having greed and power hungry humans, maybe influenced somewhat by demons and some of the demonic and occult. I don't think there's another species mixed up in that. I don't think there's enough evidence for that yet.
But you think there just as likely could be aliens from another planet, basically, or another?
No, I don't think so. I don't think there are aliens.
No? You don't think there are?
I don't think there are. I mean, I don't think that there are aliens on Earth. I suppose it's possible that God made other types of beings other places, but everything that is here on Earth is human or some hybrid of human and spiritual, like the Nephilim, mixed with some sort of demonic and angelic activity. I wouldn't say that there's some other kind of race from some other planet or something.
Okay,
Although
but
octopuses are pretty strange. They have 8 brains, one for each of their legs, and they're just like this weird animal. It's like, wait a minute, it doesn't even quite fit Earth. I think they were designed to be on Earth, but if you're looking for strange creatures, you can find them in the ocean.
oh, I know totally. And insects too are pretty creepy too.
That's
So
true. Like a hive of bees. How do they know what to do? Like they all act together, but there's like 1,000 separate individuals. It's like bizarre.
yep, I know, and they actually fly through like almost like highways in the sky. Yeah, it's amazing how orchestrated they are. And how they fly through these like pathways in the ether kind of as they whiz through, and they're like and everything they do. Yeah, so we'll just all right. So yeah, okay, so you shared your view on whether there could be another species, or kind of thing, and yeah, so okay, all right. So you don't. So if you were trying to think about what Satan is doing, basically, just again to use that phrasing, since if it would relate to kind of what your viewpoints are, you think that the best Satan's grip is right now on the Earth realm would just be through kind of individual humans, and we actually live in a real free market. They actually did really discover we're on a globe, allegedly, and I mean, but I just can't say that without saying allegedly. But yeah, but you do think that they did that, and then we're all just humans. We evolved, or do you go with evolution, or no? You go creation?
No, I don't. I think that that God created each of the individual animals as a separate special creation, but there is variation within kinds. So one type of canine creature could be a dog and come to be a dog and a wolf and a chihuahua and stuff like that. So maybe some people might call that microevolution. I would just say change within a species.
Yeah. Okay. Yeah. Yeah. So you don't go to that evolution route.
No.
Okay, but we were okay. Yeah. So, all right. So you don't think okay, and then let me ask this too then. If the shape of the Earth isn't a sphere and that was proven to you, like let's say physically, tangibly, or just whatever, the evidence becomes overwhelming in the future, whatever it may be, to where it is planar, would you then think there is a group of controllers?
No, I would say that even that could be explained through demonic activity and deception.
Wouldn't they have had to coordinate quite a bit to pull off the globe? I'm saying the one globe thing because I know there's a lot of topics.
I see what you're saying.
But yeah, the one globe thing would have to be so coordinated because I mean I can admit to that.
Okay.
It's a globe. It's very coordinated.
Yeah, because it is such a coordinated thing. I see what you're saying. The fact that all these countries have space programs and the globe is taught in every school, every high school, college, and university in every country, no matter which country it is. Okay, I guess I would agree that if the Earth is not a globe, then there would have to be some kind of pretty extraordinary collaboration and coordination from somebody to get that taught everywhere.
Yeah. No, I appreciate your just intellectual honesty on that. I do, because that's awesome. And I don't know if I've asked you that before, but I appreciate hearing your view on it. I have a family member that I've often mentioned. I won't say who it is just to leave it, just general, but I do have a family member and they're very mainstream, on pretty much everything. I mean, they definitely believe it's a globe and all the other things. They got their COVID shots, whatever, pretty much everything that you would consider more mainstream in that way, et cetera, in all those ways. And they're fairly resistant to flat earth, not completely, like a little open, but for the most part, not so accepting of even considering it. Like thinks it's just, totally not the case. And now they don't know all the detail. This particular family member, I do have another family member that does actually have quite a bit of knowledge in these fields to a degree, like in terms of just their education. But this other one I'm referring to, not as much. So they don't really know all the arguments. Either way, they trust science, they trust the mainstream thing, all that. And my point is, I asked them the same question, and they responded with, because right now, like, they don't think there's a cabal or a controllers or any of that. They do not think there's a cabal, which is your stance right now, right? You do not think there is one.
Right.
Yeah, and same with them. So they don't think there is one. And then I said to them, okay, well, if the Earth isn't a sphere, just that, if it is, let's say, planar and stationary, but if it's not a sphere, etc., does that one thing for that family member, does it flip them to, okay, there wasn't a cabal, to, okay, yes, there is one, or there has to be one? And you pretty much agreed, right? Like that, and it makes logical sense. And even that family member,
I guess you'd have to be. I think you're right.
They like never concede anything to me. It's not like they're, and they were like, yeah, there would really have to be. And I guess my final point to it is because, like, if that's the case, then, like that idea, like the greatest trick the devil ever pulled was to convince people he didn't exist. Well, that means that through the globe, if that's the case, of course, I know for you don't think it's the case, but I'm saying, okay, but if you're considering the hypothetical in your view, then if it is the case, then the shape of the Earth is actually the thing that's hiding them from most people's consideration.
Yeah. So in general, I think that the tactic of evil people and evil beings, demons and Satan, if you want to say it that way. The main tactic is deception. And so even if they don't have actual power or as much actual power as some people think they do, all they have to do is convince you that they do have that kind of power. And even if they can't coordinate all the world governments together to do something nefarious, maybe it's sufficient to convince enough people that they have got all the world governments together somehow. So in my view, the perception of, their tactic is deception. And it might not be that there's actual coordination, but that enough people think there is coordination that may accomplish the same goals for them.
Okay, I think I hear where you're going with that. I've thought about that myself. I think if I'm relating to what you're saying, which is, like even like, well, okay. So are you saying that a tactic they would use is to convince people that they're more powerful than they actually are? Essentially?
Right. And then, fear goes into that too. If you're afraid of something, even if they have no power, like a dog's bark is worse than its bite in that case. So, yeah, I would put fear in there too.
The Wizard of Oz when he's
right. Pay no attention to the man back there. Right.
Yeah, it sounds all scary and she's all frightened, but it's just an old man like behind the curtain. Yeah, no, I mean, dude, that is interesting. And I mean, in terms of the idea of a cabal or some kind of organized group that's going on, like, okay, here's one. I'm just spitballing and just throwing this out there for fun. But like, what if they're not like these really evil? I mean, some people think they're like reptilians or like another species, or they're like some kind of just like ruthless. What if they're just like a bunch of old men? And then they're just really good at deceiving. And then they've convinced people like that there's an Illuminati, now even like the kind of Epstein type stuff, like with the children or whatever, like, for example, do they really do that? Or is that a psyop? Now, I would like to think it is a psyop because that means children are not being hurt in those ways, although that's still happening in other parts of the world, which is an issue as in and of itself. But I think we would all hope that it's not happening at some crazy elitist level of billionaires and like the creepy things that people have said and talked about and whatever. When it comes to all that, like, unfortunately, though, that may be true. Sadly, though, that's the problem. Because very wealthy people like to do criminal, crazy things, and why they're into that is very weird and just bizarre. But it's demonic, I suppose, if we go that route. Like, it's just evil. But anyways, it's just one example that I think has been talked about. The idea that what if they like okay, if there is a group of controllers, but they're not really as dramatic of like a threat, like you said, to where then they like made up a bunch of stuff to put in people's minds. That they're way worse or whatever, to, like you said, because then it makes people think that they have more power if you give them this, like, some people give them almost like a godlike level of control or something,
Yeah, it's hard to tell. In general, I think that it's probably a mix. So I think you're right about that. I think there probably are people who are genuinely very evil, taking as much advantage of children as they can. But I suspect that it's far fewer people than, if it's 1 or 2 billionaires doing that, then people might assume that all billionaires are like that. So, for example, not even just billionaires. I would say that Bill Clinton and Obama are not involved in any of that type of stuff, but Jeffrey Epstein definitely, was definitely involved in something like that, and there might even be demonic activity. So, because Epstein was involved in that, some people assume that everybody he ever talked to must have done the exact same thing. So, I don't know. And it's going to be hard for us to know, right? I mean, how would we know if one particular person, how evil they are? I don't know.
Yeah. Well,
money is the root of all evil.
Right. That's not true, by the way.
Well, I mean, dude, it does seem like it's kind of
the love. No, this is what the Bible says.
money.
The Bible says the love of money is a root of all kinds of evil.
That's it. The love of money is the root of all sorts of evil. That's what I.
No, and I hear that one too. Like, yeah, from the biblical.
But not all evil.
But that's kind of turned into like money is the root of all evil. Like that is kind of a common phrase nowadays. Like whether that was adapted from the biblical one, but I guess in my view, currently, like well, just real quick, whatever. I won't go on a long time, but just whatever's going on from like 17 to 1800s, and then like World War One. Well, yeah, they set up the Federal Reserve, World War One, the Great Depression, and then World War Two, and then we're in this thing now. And all I know is that it does seem like there's enough history to indicate that they changed us from the gold standard, well, originally from the silver standard, then the gold standard, into this current money system. And then this current money system all seems based on like the Federal Reserve and inflated, basically like monopoly money. So in that case, it does. And I do think the people running it are evil. So like in a sense, like money is the root of all evil right now. It doesn't mean that gold is necessarily, but so I kind of do resonate with that idea in a way.
Yeah, I would say the sin of Western civilization is greed and money, whereas maybe other civilizations have been all about power and taking over, or maybe even sex cults.
Conquest.
Conquest, yeah.
Money, it says in
Not
the
so much
Bible,
conquest nowadays.
it says all kinds of evil.
Yeah,
So that would be
also-
like all kinds, not excluding any kind, because it's saying all kind. All,
No, I don't
all
think it
kind.
means that it's every kind of evil. I think it means that there's all
then-
sorts of evil, not all
And then money
evil.
itself, right? Money itself isn't just
It's nuanced.
U.S. dollars or rubles or whatever. It's also mammon. It is that which is of a tradable value, or one that we would put equity on and then trade.
So yeah, financial wealth is seen as a blessing in the Old Testament, especially in the Proverbs. So it's not money; it's the love of money that is a root of all kinds of evil.
Yeah, the love of money. Thank you for correcting that. The love of money is the root of all kinds of evil. And then money, the love for that thing, that intangible thing, right? It's not just U.S. dollars or paper notes or gold or silver. It can also be sex. It can be power, control. That which the one deems to be constituting value, holding to be equitable. Not to put too much depth into that, but there's quite a
Matthew,
bit there.
did you go to seminary?
Yeah, no, it was well said. Yeah.
Okay.
I did.
Well, so but
I did study. I did take some Bible classes in undergrad, and I go to church regularly, so I hear theology stuff there too.
Well, I guess because we were talking a little. Well, sorry. Go ahead. What were you?
Monty Python.
You were saying you go to
So
church.
does
Matt?
that mean like all billionaires are evil? Is that what it means?
No.
Well, Matthew, kind of okay. So we were on a few kind of topics there. So we were talking about like either like Satan or like demonic energies, to what depth they go in this world, and that's why I was asking you like do you think, like, I use that term controllers, the controllers sometimes, or like there's like the Illuminati term or cabal, like if there's a cabal. So we're talking about that, and then like how deep do you think that goes, and now we're like to the kind of money and like money's expression. But yeah, and then you were agreeing that if the Earth's not a sphere, then there would have to be some kind of group because of the coordination. And then I guess I just want to maybe link that through to like also, would that then imply that money would also be like a spawn of their doing as well, like the current money system, and that's been orchestrated, in a way that's not fair? Like, do you agree with that?
Yeah, I don't know if there's a lot of orchestration involved. It's more like all of them were trying to make as much money for themselves as possible. I have a hard time believing that they would orchestrate in ways that wouldn't be beneficial to themselves. Now, that said, maybe some cooperation among these evil powers might be how they're trying to make more money for themselves. But I see them more as in competition than coordination. Just from what I know of human nature.
I had the question of the question was just asked of are billionaires evil? All billionaires evil? What I would like to know is, how about trillionaires?
Unfortunately, like nowadays, unfortunately, I would
Sorry.
imagine a large percentage of billionaires are probably like sociopaths or even psychopaths, actually, and maybe evil, because a lot of the way they've made that money, if you think about like what avenues in this world can you make billions at, pharmaceuticals, oil, when you start looking, the media, etc., music industry, film industry, you start looking into, just where the places you even could make that much.
Selling books. I mean, that's what Bezos did.
J.K. Rowling did. She's the first author to become a billionaire.
No, there are some that maybe did make it, exactly, in other ways, or even like the Amazon.
There's a level of obsession.
Microsoft.
Yeah, exactly. Yeah, there's a level of obsession required to reach a billionaire status, because most people settle. Yeah, so most people settle, and once they become millionaires or multimillionaires, that's it. You don't need to go any further. I'm happy.
What about
I've got
hundreds of
100 million? They just quit. They just quit us.
Well, I mean, 100 million you didn't just quit at. I mean, when you get to like 40, 60, 70 million, that's like quitting. You get up to like a couple hundred million. That's like, you didn't really quit. At some point, you just kind of said, I'm going to focus with my hundreds of millions of dollars elsewhere instead. I'm not going to just sit here and spend the rest of it on money.
That's it. And then go do something else with it.
That doesn't mean you're not obsessive.
Yeah, that's true. That's true. I'm just commenting that in order to get to $1 billion, you have to be driven to an extent that most people can't comprehend.
Well, I don't know if it's always just about harder work, though. I bet there's a lot of people in even like other jobs that make more, sort of under 100,000 a year that probably work way harder than billionaires in some cases. Yeah, there obviously are some billionaires that probably are very hardworking, but in terms of I just think you have to be in an industry that usually has a pretty dark thing attached to it. Not in all cases, but because I mean, there's some that like we're saying, because like if we're just talking about like tens of millions, like there's definitely like artists and musicians and people, but if you're talking about like billions, it's usually in some kind of industry that's probably immoral, you know, at the end of the day,
How about
to get to
Hollywood
that level.
monopoly money?
Surely not. An industry isn't immoral unless it is immoral. Surely it's the people in the industry that make it immoral. Like the music industry isn't immoral because it's the music industry. It's because there are people in there that are immoral.
Yeah, I hear you, but such a bulk of it is immoral. But yeah, that even if you're a good musician in there, you're like the odd man out in a way. Like if you're a good person.
Music is an institutionalized start too. Like it had a hard monopolized grip on people producing tunes and song, especially playing it on massive airways. So I mean, it did start institutionalized, monopolized, kind of like the motion picture industry.
It was
I was hoping
necessary.
Go ahead.
Yeah, it was necessary, but that was correct because at that time there was no way to have large distribution of any content of any kind, including news and including music. And so you had to have a very large company with deep pockets to be able to finance album production and tours and sell the production and selling of merchandising. Specifically, first of all, of course, records, distribution of records, that's expensive. And so you had to have gatekeepers to make sure that the bands that they were signing could sell large numbers of records. And that was really the only, and when they found them, of course, they latched onto them and they were great.
Right, which really meant you had audio recording and playback equipment and a massive radio transmitter in several locations and receivers. So that way you could interweave your connected network of people to actually publish it, which is crazy. I mean, you think about how much money one had to have. Very deep pockets.
Back in the day, nowadays you can self-publish a lot of stuff, books and everything else. Back in those days, you had to go to publishers to get a book published. There's no way to publish it yourself. You couldn't afford to get it bound, and then there's no way to get mass distribution in order to make enough money to make it worthwhile. And then for music artists, it was the same thing. That's not the case anymore. But back in the day, that was the case. I don't know if anyone's heard of Kate Bush, but she was discovered. She just did some songs on a piano and recorded them on a tape.
Right, they've been running up that hill back again.
Yeah. So for her, someone got hold of one of her tapes. I don't know. Maybe someone could look this up. But David Gilmour, some people in here will know who that is, discovered the tape or got the tape or was given the tape. And he was the one who was instrumental in getting her a record deal, is what I've heard. And there are lots of instances like that. The band Boston is another one where they just happen to be heard by the right guy who then passed the knowledge of that great sound to someone who could pull some strings and get the band a record deal. But that's how it was done back then.
Yeah, those monopolies extended like well into the 80s, by the way. Like
it
started early, but it extended into very recent modern history. So,
absolutely true. Absolutely true.
Yeah. Yes.
Now, though, I mean, there's artists I listen to on YouTube, and they're incredible. So that's has anyone heard of Rick Beato? Anyone in here who's into music has heard of Rick Beato?
No, not me.
His name looks like Beat with an O at the end, Beato, but it's Beato. No, okay, I'm sorry. Just check him out. He's if you're into music at all.
You drop if I'm gonna look at it, I'd need a link because Beato, I don't want to type that in, but if you want to type it in, then I'll
yeah, it's like the word beat with an O. Rick Beato. He's actually based in Atlanta. That's why I mentioned him.
So I was going to tell Matthew this, and Matthew left, and that was a little bit sad because I wanted to tell him this. So I've got he was saying how he felt like there'd have to be a group, right, and they're all kind of would have to be against each other, and he felt like it was more competition that they would have, that they wouldn't really be working together. They'd be working kind of in more like a Roman Games sort of Olympic Games sort of fashion where they're competing. Like maybe
but the competition itself is part of the deception.
Yeah. Like the Howard Hughes, like the TWA versus Lockheed Martin in World War II. That kind of So like it's the Howard Hughes versus the world type idea. But for people who don't know who Howard Hughes is, by the way, I feel like
people don't know who. Yeah, it is remarkable. You ask people, they don't know who Howard Hughes is.